Hello again. So now what we're going to do is we're going to take everything we've learned about exponents, the four properties of exponents that we talked about, the product of powers, the quotient of powers, the power of a power, and the power of a product or quotient, and we're going to combine that with what we know about positive integer exponents, negative integer exponents, and zero exponents into big problems where you have to use all the properties and use all what you know about the different types of exponents. So we're going to do three problems that get progressively harder, I think, and we're going to work those through. And again, I would suggest that as soon as I give you the problem that you stop the video, work the problem yourself, and then turn the video back on and finish and see how the problem was solved, or at least how I solved the problem, which isn't necessarily how you might do it. There's lots of different ways to do these. So let's start with the first one. How about this one? I have 2x to the 0 y squared over 4x to the negative 4 y to the fifth. This tests all of our different types of exponents. We have zero exponents, we have positive exponents, and we have negative exponents. So let's take a look at this. Let's deal with one piece at a time. Let's deal with our numbers first. 2 over 4. What's 2/4? 1/2, isn't it? Okay. Let's take a look at our x's. Alright. What you should notice right away, I hope, is that we have an x to the 0 on the top. Now we could just simply eliminate it because it's 1. And that's probably what I would do. I would just say, nah, I don't have to worry about that x to the 0. Okay, that's 1. And then x to the negative 4. We know what to do with negative exponents. I'll remind you, you write them on the other side of the fraction as a positive. So that x to the negative 4 in the denominator becomes an x to the positive 4 in the numerator. And then our last step here is our y's. I have y squared over y to the fifth. The rule for our quotient rule was, or our shortcut was, to subtract the smaller number from the bigger number, 5 minus 2, and then put the answer to that where the larger exponent was. 5 minus 2 is 3, and since the 5 is bigger than the 2, we're going to put that answer on the bottom. And let's just write that in a better form. We don't need that 1 on the top. X to the 4th over 2y to the 3rd. You don't need to write a 1 on the top unless that's the only thing that's left. Unless you've canceled out everything in the numerator, and then you would write the 1. But otherwise, a coefficient of 1 is an understood coefficient. Okay? Let's do our next example. This one's quite a bit bigger. I've got xy to the negative 2 times x to the negative 3 y to the 4th squared over x squared y to the negative 3 times x to the 3rd y to the 5th. If you want to work it out yourselves first, stop the video, work it out, and then start the video again. Okay, so let's finish this. Let's work this out. Now, there are actually a couple different ways to deal with this. What I would do is go ahead and expand these power of a power portions first. That's what I would do. So let's go ahead and do that. Xy to the negative 2, and the rule is that we multiply exponents, right? So x to the negative 3 squared is x to the negative 6. Y 4th squared, 4 to the 2nd power. We multiply. 4 times 2 is 8. Okay? On the bottom, we have 2 times negative 3. That's x squared times the negative 3 is x to the negative 6. Y to the negative 3, that's 1 times negative 3, times x to the 3rd, y to the 5th. I should point out to you that another way to do this problem, and it would be perfectly okay, there's nothing wrong with it, would be to take, write this in a different color, to take this whole mess right here, that whole thing, make it to the positive 3 and move it up here. So you would actually have up on the top an x squared y to the third. Move it to begin with. You don't have to. It's not what I would do, but you could do that. So let's just assume that you didn't do that. In fact, I'm going to erase it. But just to let you know that you can do that, there's nothing wrong with it. All right? So let's go back to what I was doing here. Now, there are two different ways to do this. And again, there's lots of different ways to do these problems, and they're all perfectly okay. One way to do it is to go ahead and move all of your negatives first. Everything that has a negative exponent moves to the other side as a positive. The other way to do it is to use your product rule and go ahead and add exponents together and then move them. I personally prefer to move stuff first because I don't want to have to deal with adding negative numbers. Okay? So I'm going to do this both ways just to show you both ways to do it. First way to do it would be to move everything that's negative first, which means we're going to leave everything that's positive, everything that has a positive exponent where it is. I have an x that's positive right here, x to the first, and I have a y to the eighth that's positive, has a positive exponent. So those are going to stay. On the bottom, I have an x to the third, y to the fifth, which both have positive exponents on them. Okay? Now, on both sides of this fraction, I have two negative exponents. On the top, I have a y to the negative 2, x to the negative 6. My rule for negative exponents is move them to the other side and make the exponents positive. So I'm going to have a y squared x to the positive 6 on the bottom. Now look at the bottom. I've got this set of terms here, this set of factors. X to the negative 6, y to the negative 3 is going to move to the top as an x to the 6th, y to the 3rd. Okay? Now we can use our product rule. X times x to the 6th is x to the 7th. Y to the 8th times y to the 3rd, add exponents, is y to the 11th. X to the 3rd times x to the 6th is x to the 9th, and y to the 5th times y squared, add exponents, is y to the 7th. So far so good? I hope so. And then use our quotient rule. Our quotient rule said that when I've got this situation here, same base, and I'm dividing, I subtract the smaller number from the bigger one and leave it where the bigger one was. 9 minus 7. 9 minus 7 is 2. And since the 9 is bigger than the 7, I'm going to put that answer on the bottom. And with the y's, 11 minus 7 is 4, and 11 is bigger than 7, so I'm going to put that answer on the top. So my final answer is y to the 4th over x squared. Now some of you may have been saying, wait, can't you way back here, don't you have an x to the 6th on the top and the bottom? Can't you cancel them out? Sure you can. Why not? That'll work for you. You still have to do your quotient rule when you're done, but it'll make your quotients a little easier, your subtractions a little easier, but you can get rid of them there if you want. Now, what about the other method? Remember what I told you. I said you could also have, at this point in the problem, right? Turn that off. At this point in the problem right here, you could have added your exponents together to begin with, before you move them to the other side. Let's do it that way, to show you that either way works. I'm just rewriting the problem because it's all messed up there. So let's add them. We've got a 1 plus a negative 6 is a negative 5. Y, negative 2 plus 8 is 6. On the bottom, x to the negative 6 times 3, x to the negative 3 is negative 6 plus 3, which is x to the negative 3. Negative 3 plus 5 gives me y squared. Now, again, you've got a number of different ways to deal with this. You could simply switch these two. This x to the negative 5 is going to come down to the bottom as an x to the positive 5, and the x to the negative 3 is going to come up to the top as an x to the 3rd. The y to the 6th and the y squared are going to stay where they are because they have a positive exponent. 3, I've got x to the 3rd on the top, I've got x to the 5th on the bottom. 5 minus 3 is x squared. And that's going to stay, the answer is going to be on the bottom because the 5 is bigger than the 3. And for our y's, 6 minus 2 is 4. And the 6 is bigger than the 2. 6 is bigger than the 2, so that's going to stay on the top. We get the same answer. Okay? Again, many different ways to solve these problems, and they're all equally correct. Let's look at one last problem, and then we will be done with negative 0 and positive integers. And then all we have left to deal with is rational exponents, fraction exponents. Y to the negative 2 over 2x squared y to the 3rd times 2y to the 4th. And we're going to raise all of this to the negative 3 power. Uh-oh. Well, let's take a look at this. What was my rule? My rule said that a negative power is the reciprocal of the positive power. Now, we didn't talk about this in our negative exponents video, but we can talk about it now. If I raise a fraction to a negative exponent, the positive is the reciprocal of the negative. Can't I just take the reciprocal? Sure I can. The positive is the reciprocal of the negative. The positive is the reciprocal of the negative exponent. The fraction that was raised to the negative exponent, we make it a reciprocal, and our exponent becomes positive. Okay? Because all of this stuff, everything in the numerator would have moved down to the denominator with the negative exponent. Everything that was in the denominator would have moved up to the numerator with an negative exponent, wouldn't it have? It's not the only way to do the problem. Actually, I'm going to do it a different way for you in just a minute as well. But for now, let's finish this. So now we can either simplify what's in the parentheses and raise to the 3rd, or we can raise to the 3rd first and then simplify. I prefer to simplify what's inside first. What happens to this y to the negative 2? It comes up to the top. So I have 2x squared y to the 3rd times 2y to the 4th. And that y to the negative 2 is going to come up to the top as 2y squared. Just y squared. That's all raised to the 3rd. Let's do some combining inside. I have 4. How many x's do I have? Just 2. And how many y's? 3 plus 4 plus 2 is to the 9th, isn't it? Sure is. To the 3rd power. Okay? Power of a quotient. 4 to the 3rd power is not 12. 4 times 4 times 4, that's 16 times 4, which is 64. X to the 2 times 3 is x to the 6th. Y to the 9 times 3 is y to the 27th. There's my answer. 64x to the 6th, y to the 27th. Okay, now, what would have happened if instead I hadn't flipped the fraction, but taken everything to the negative 3 power to begin with? Let's try that. Let's see what happens. It's not the way I would suggest you do it, but you could certainly do it that way. Y to the negative 2 to the negative 3, negative 2 times 3 is positive 6, isn't it? What am I going to have on the bottom? I'm going to have 2 to the negative 3. I'm just going to leave it that way for a minute to show you something. Then I have x to the negative 6, don't I? Negative 2 times 2 times negative 3 is negative 6. Y to the negative 9, negative 3 times negative 3. Then we've got another 2 to the negative 3. And then we've got a y to the negative 12, don't we? All I did was take everything inside to the negative 3 power. Okay? What's my rule for negative exponents? I can take everything that's negative, and that's everything in this denominator, all of it, and move it to the top and make all of my powers positive. That's how we deal with negative exponents. So Let's do that. We've got a y to the 6th that's already in the numerator. That gives me a 2 to the 3rd, an x to the 6th. All I'm doing is making a positive, a y to the 9th, another 2 to the 3rd, and a y to the 12th. What's 2 to the 3rd? 2 times 2 times 2 is 8. It's not 6. So 8 times 8 is 64. X to the 6th, that's our only x term. And y to the 6th plus 9 is 15. 6 plus 9 is 15, plus 12 is 27. And lo and behold, we got the same answer. Okay? So hopefully that answers all of your questions concerning the 4 properties of exponents that we covered and dealing with 0 exponents, positive integer exponents, and negative integer exponents. Next up, before we leave exponential expressions, is going to be fraction exponents. Thanks.